So, ayun, ang discussion natin is just the continuation of the derivation. We have here yung the derivatives na siya, na part 3 na. Okay, for our objective for this topic, at the end of this session, students will be able to understand and get the derivatives of a function using the chain rule and implicit differentiation and apply higher order derivatives in interpreting derivatives. So, yung focus natin, again, ang focus natin is, we have here yung mga topics natin for today. For today, we have yung first is the chain rule. And then after natin mag-discussion sa chain rule, next naman natin is we have the implicit differentiation. And then followed by the higher order derivatives and then the interpretation of derivatives. Okay, let's start with the chain rule. Ayan, chain rule. We have yung example dito for the chain rule. Let's say we have yung composite function. Composite function, yung problem natin is we have y is equal to 6x minus 10. So, itong 6x and 10 is pwede siyang i-divide by 2. So, same lang din siya with y is equal to 2 times the 3x minus 5. And then, we have here, variable lang siya if we will going to use yung u as the value of 3x minus 5. So, kapag ginamit na natin yung value ng u for the 3x minus 5, yung y natin can be written as 2u. Kasi same lang naman siya dito with y is equal to 2 and then ito yung nireplace natin by u. And then for the computation, we have here, if meron tayong dy over the dx, ito yung derivative natin with respect. We have the derivative of y with respect to x. Let's say we have yung value natin as y is equal to 6x minus 10. Kapag tayo nag-derive ng value, we have yung constant times nung x natin. Ang value na lang natin is yung constant value which is yung 6. And then for the value naman na constant lang siya, considered as 0 na to. Kaya yung dy over dx natin is equivalent sa 6. And then we also have naman dito the derivative of y with respect to u, which is yung value natin ng y is equal to 2u kasi yung u natin is nireplace natin for the 3x minus 5. Kapag nag-derive naman tayo ng value ng na same lang, we have the variable and we also have yung constant value. So yung variable na yung constant value na lang yung maiiwan. So the derivative of y with respect to u is equivalent to u. And then for the u, if we will going to derive 3x minus 5, the value here for the derivative of u with respect to x is equal to 3. And then pinakita lang dito, since we have naman yung value daw for the derivative of y, which is yung 6, and then itong value na to, yung u natin, u is ito lang din siya. So kapag minultiply daw natin si 2 times 3, equal lang siya. So therefore, we have yung dy over dx is equivalent to dy over du times the du over dx. Yan yung formula natin for the chain rule. Another example is, we also have here naman daw, we have yung y is equal to 5u minus 2, where yung u daw natin is 3t. So, kabaliktaran siya nung value natin kanina. Kung kanina, yung value natin is nireplace natin by u. Dito naman, given yung u, and then may binigay lang tayong value ng u, which is yung 3t. Then, equivalent lang daw si 5u minus t sa 5 times 3t minus 2. And then, i-apply lang ulit natin yung derivation natin. For first is we have yung sa y is equal to 5 times the 3t minus 2. Dito lang, same lang siya. Yung value natin, i-derive natin. So 5 times 3t is we have the 15t minus yung value natin ng 2. And then for the derivation of 15t, we have yung 15. And for the 2 naman, or negative 2, equivalent lang siya sa 0. Therefore, we have the value of dy over dt is equal to 15. While for the y is equal to 5u minus 2, i-derive lang natin siya. For 5u, we have 5. And for the negative 2, 0 lang din siya. So therefore, we have yung dy over the du equal siya sa 5. And then, for the u naman natin, which is equivalent to 3t, derivation nito is equivalent sa 3. Therefore, we have yung du over dt natin is equal to 3. And then checking, so we have the dy over dt as 15. And then imo-multiply natin si dy over du kay du over dt, which is 5 times 3. So equal lang siya. Therefore, we have again yung mismong equation natin or yung mismong formula natin, which is dy over dt is equal to dy over du times the du over dt. And then another example, so third example natin for the chain rule. Example naman natin dito is we have a polynomial which is equivalent to y is equal to 9x squared plus 6x plus 1. So ginamitan lang siya ng algebra. So we have here yung y is equal to 3x plus 1. Open and close parenthesis is squared. So kapag in-expand natin yung 3x plus 1 squared, equivalent lang siya dito sa formula natin na to. And then gagamitin daw natin yung value natin na 3x plus 1 as u. Therefore, we have yung y as equivalent lang siya sa u squared natin. So, kapag nag-derive ulit tayo, derivation of dy over the dx, ito is gagamitin natin ng power rule, which is we have yung 18x. And then for the derivation of 6x, we have 6. And then for 1, ito is equivalent lang siya sa 0. And then for the y is equal to u squared, power rule lang din yung gagamitin natin. We have yung dy over du is equal to 2u. And then for the u naman natin, which is yung 3x plus 1, the value of du over dx is equivalent to 3. And then here, pinakita lang natin na yung dy over the du is equal to 2 times the 3x plus 1. So derivation nito, we have naman, wait lang, hindi pa, ito is minultiply pa lang siya. Minultiply pa lang yung 2 sa 3x plus 1. So we have yung 6x plus 2. And then for this problem, itetest natin if equivalent si dy over dx kay dy over du times the du over dx. So yung value natin for the dy over dx is 18x plus 6. And then for the 2u natin, which is ito, equivalent lang siya is 6x plus 2. And then for the du over the dx natin is 3. So kapag minultiply natin siya dito sa value natin, if ito is magiging 18x and ito is magiging 6. So equal lang din siya. Therefore, we have yung pattern as the chain rule natin, which is dy over dx is equal to dy over du times the du over dx. And for the chain rule, we have again yung formula na ito. Ayan. So ito yung formula. And then we also have yung, kung recall lang natin, we have the f of g or yung composite function natin of y is equal to f of u and yung u natin is equal sa g of x. Then therefore, ito yung first derivative or ayan, f of g prime natin is equal to f prime at u is equal to g of x multiplied dun sa g of x natin at x. Same lang siya dun sa formula natin. Let's say ito yung problem natin. Ang given natin is we have yung function of f of x and then yung g of x natin. For the f of x, we have the sine x, and for the g of x, we have the x squared minus 4. And then we need to find yung f of g prime natin at given x natin is equal to 2. And then for dun sa kanina natin na formula, we need to get yung f prime and then yung g prime natin. So for the f prime, or yung first derivative ng f of x natin, derivative of sine x is equivalent by the positive cosine x lang siya. And then for the derivative naman natin ng g of x natin, which is x squared minus 4. So for the x squared, we have yung 2x. Power rule lang din ito. And then for the 4 naman is equivalent lang siya sa 0. Therefore, we have yung first derivative natin is equal to 2x. And then let's say, gagamitin na natin yung value natin for the 2. Yung x is equal to 2. For this equation, we have yung g of x is equal to x squared minus 4. So, g of 2, given na yung 2 natin is yung x natin, is equal to, ito yung x squared natin, which is 2 squared, which is equivalent sa 4, and then yung minus 4, equivalent lang siya sa 0. So, we have here yung f prime of 0, and we have yung g prime na given is 2. Isa-substitute lang natin yung value. Let's say yung cosine natin is 0 lang yung x natin, and also for the g prime natin of 2, so we have yung 4. Therefore, we have yung itong value for the cosine, and itong kabuuan na to is 1 times 4, so equivalent lang din siya sa 4, yung value na yun. And then, ito yung other way ng pagko-compute natin. Same lang siya sa, or I mean continuation lang siya dun sa problem natin. Balikan lang ulit natin yung problem natin. So, yung problem natin dito, we have yung separate, we have yung f of x natin, and then dito is g of x natin. So, yun yung mismong problem natin. And then, since combination siya, dito na sa mismong problem natin is naka-include na siya. So, we have yung f natin, naka-include na si g of x. Therefore, si sin natin before, si f of x natin kanina is si sin x, which is yung g of x natin is itong x squared minus 4. So, for this equation, we have sin x squared minus 4. And then, kukunin lang natin yung mismong dy over du and the du over the dx. So, for the y, we have yung sin u natin, and for the u natin, yung u natin is ito, yung x squared minus 4. And then, we have the derivative or dy over the du, equivalent lang siya sa cosine. And then, derivation ng du over dx natin is we have yung 2x. And then, application lang ng formula natin for the power rule, which is dy over dx is equal to dy over du times the du over dx. We have yung cosine natin, which is the dy over du, and multiplied natin siya sa du over dx, which is the 2x. And then, after nun, so we have here na yung pinalitan natin yung value ng cosine u. Yung cosine u natin, again, is x squared minus 4. So, kaya tayo dito nagkaroon ng x squared minus 4. And then, the value of x kanina. So, yung value ng x natin is given natin is 2. So, substitute lang natin yung value ng 2 in here. So, we have yung cosine 2 squared minus 4 times 2 times 0. So, dito, since 4 minus 4 lang siya, magkakaroon na tayo ng cosine 0. And then, here is we have 4. So, the value of dy over the dx is equal to 4. So, same lang siya dun sa kanina natin na ang value natin is 4. And then, another example natin naman dito, yung pinaka-mabilis or faster way natin to find yung derivative is, we have here yung kukunin na natin kagad yung first derivative natin. So, kanina, ang given natin is meron tayong f of x and g of x. Dito is magkasama na siya. And then, ginamit na natin yung value ni y is equal to sin x squared minus 4. So, derivative natin, first derivative, we have cosine x squared minus 4 times d over dx natin, which is itong nasa loob niya. So, derivative nito, which is equivalent siya sa 2x pag dinerive natin to. Kasi yung x squared is equivalent sa 2x and yung 4 is 0 lang siya. So, we have the cosine x squared minus 4 times the 2x. And then, if we have yung value as yung x natin is equivalent sa 2, we have again here, yung x squared is equivalent lang siya sa 4. So, 4 minus 4 is cosine 0. And then, 2 times 2 is 4. So, cosine 0 times 4 is equivalent lang siya. For the first derivative is equivalent sa 4. And so, ano siya, tatlong way kung paano tayo nagsisolve. Pero, same lang siya ng, magkakaiba ng solution pero same lang siya ng answer. So, next nating example is part pa rin siya ng chain rule natin. So, example number 2, we have d over dx cosine squared 3x. So, ito yung given natin. Or, equivalent siya with the value of d over dx. We have here yung cosine 3x raised to 2. And then for the derivative nito, kapag nag-derive tayo, una, we have yung 2, which is yung exponent natin, and then cosine 3x, and then derivative ng cosine 3x, itong part na to. So, ganun siya. And then, after nun, sabi natin kanina, derivative nito, so we have here dito is copy lang, so we have 2 cosine 3x, and the derivative of cosine 3x is we have yung derivative nitong 3x, and then derivative ng cosine 3x. So we have here, for the derivative of cosine 3x, we have the negative sine 3x, and then the derivative of 3x is 3. Therefore, we have the negative 2 cosine 3x times the sine 3x times yung 3. And then, ang value natin is we have the negative 6. Ito, minultiply na rin natin dito sa 2. So, we have the negative 6 cosine 3x sine 3x. Yan yung solution for the example number 3. And yung other formulas lang natin. So, before naman kasi ginagamit na rin naman natin to for the other discussion natin. Na-discuss na rin natin yung power rule, yung mga related trigonometric function for the derivation. Let's say ito yung sa power rule natin. We have yung d over dx, u raised to n is equivalent siya sa n times the u raised to n minus 1 du over dx. And then for the sine naman, or we have yung kukunin natin yung value ni sine u, equivalent niya is cosine u du over dx. Kapag naman si cosine u yung kukunin natin yung derivative, we have the negative sine u du over dx, or kapag naman si tangent u, yung derivative naman niya is secant squared u du over dx, and so on. Kasi pwede pa rin natin dito kunin yung mga other derivatives natin for the cotangent, cosecant, ayun. So we have here lang yung note that the formulas in other references are written as yung u prime, or instead na du over dx. So pwede tayo magkaroon ng gantong term. So pareho lang naman siya, parang first derivative lang din. And then the most common mistake on finding the derivative is to forget the use of the chain rule. So every derivative problem could be taught as a chain rule problem. So example daw natin is we have we need to find the derivative of x squared. So we have here the derivative of outside function, which is yung 2x, and the derivative of the inside function d over dx of x. Yan. So the derivative of x is 1 lang siya. Ayan. So therefore, kapag kinuha natin yung derivative ng x squared, equivalent lang siya sa 2x. Or yung isang way naman na madali naman lang natin gagamitin dito is the power rule lang, which is yung pinakita kong kaninang formula. And then the chain rule enables us to find the slope of parametrically defined curves. Example lang naman to, again, we have here na yung chain rule natin, discussion natin ng chain rule natin, which is the dy over the dt is equal to dy over dx times the dx over the dt. And then sabi dito is divide both sides by dx over dt. So if we will going to divide both sides by dx over dt, we have dy over dt over the dx over the dt is equal to dy over dx. So, ito na yung slope, yung formula natin. The slope of a parameterized curve is given as this formula. We have the dy over the dx equals sa dy over dt over the dx over dt. And then let's say we have the example for this problem. The given example is x is equal to 3 cosine t and y is equal to 2 sine t. Yun daw yung given natin. Kukunin natin yung value for the dx over the dt. So, derive lang natin based dito. So, we have the negative 3 sine t, and for the dy over dt, derivation lang niya is 2 cosine t. And then, if we will going to get the value for the dy over dx, sabi natin kanina is naka-divide lang siya. We have here the value of dy over the dt and the value of the dx over the dt. So, we have 2 cosine t over the negative 3 sine t. And the value for cosine over sine is equivalent lang siya sa cotangent. Therefore, ang answer natin for this problem is we have negative 2 over 3 cotangent t. Proceed na tayo with the implicit differentiation. Iba namang discussion, pero same lang ng mga application ng mga derivatives. Yung kanina, yung mga power rule, possible pa rin siyang gamitin natin for the problem. Let's say we have here yung value natin. So sa function ng sa algebra, given tong formula na to, we have the x squared plus y squared is equal to 1. Let's say ito yung problem natin. And then, derive natin siya, which is we have the d over dx x squared plus the d over dx y squared is equal to d over dx 1. And then for the derivation, we have the derivative of x squared is equivalent lang siya sa 2x. Since with respect to dx naman siya. And then for the y, we have the 2y, and then we have naman dito use of the chain rule, which is the dy over the dx, and then the derivative for the 1 is equivalent lang siya, since constant value naman siya, equivalent lang siya sa 0. And then for the next problem, para makuha lang natin si dy over dx, itatranspose natin sa kabilang side si 2x. So kapag nilipat natin si 2x, we have the negative 2x. And then divide lang siya both side by 2y. Ito. So we have the dy over dx equal to negative 2x over the 2y. Since pareho naman siyang 2, pwede na natin siyang i-cancel. So the value for the dy over the dx is equivalent to negative x over y. And then another example here. For the next example, since we have the value naman for the sine, yung problem natin kanina, ang given lang natin is we only have the value of x squared and we also have the value for the y squared. But for this problem, we have na yung sine y. So 2y is equal to x squared plus sine y. So same lang yung gagawin natin dito for the problem kanina. We have the d over dx for the 2y, and then d over dx for the x squared, and d over dx for the sine y. For this value, derivative of 2y, since with respect naman siya dx, and then application ng chain rule, we have yung derivative for this is we have the 2, and then dy over dx. And then for the 2x, we have, x squared, we have 2x. And then for the derivative of sine y, we have yung cosine y dy over dx. And then we need also to get yung value again ni dy over dx. So lahat ng value naman dito, we have yung dy over dx kay 2 at saka kay cosine y. So pagsasamahin natin sila, we have 2 dy over dx minus the cosine y dy over dx. And then sa kabilang side or sa right hand side, we have the 2x. Kasi ang nilipat lang natin dito is yung cosine y dy over dx. Kaya siya naging negative value. And then same lang siya with the dy over dx times the 2 minus cosine y equals sa 2x. And then divide lang both side by 2 minus cosine y. Therefore, the value for the dy over dx is equal to 2x over 2 minus cosine y. So ito yung technique na tinatawag natin na implicit differentiation. So yung first natin is differentiate both sides into x natin, and then next natin is isosolve natin yung value for the dy over the dx. Okay, for the example number 1. For the example number 1, may given na tayo ditong equation of the tangent line and also the normal to the curve. So we have the x squared minus the xy plus y squared equals 7 at negative 1, 2. So we have yung value na yan. So, for this value, we need the slope. Since we cannot solve for y, we use implicit differentiation to solve for the value of dy over the dx. Ayan. So, kanina, may mga differentiation or derivation tayong ginagawa. Same lang din dito. we have daw for the x squared, derivation nito is we have the 2x. And then for the xy natin is we have yung x and then dy over dx and then plus y natin. And then for the y squared, we have naman dito yung 2y dy over dx. Ito pala is ano na siya ha, shortcut na siya, which is yung application lang to ng product rule natin. And then for the 7 naman, yung value natin ng 7, since constant lang siya, is equivalent lang siya again with 0. And then for this value, we have the 2 minus x dy over dx minus y plus 2y dy over dx is equal to 0. And then lahat ng value again with respect dito sa dy over dx, so pagkasamahin lang natin siya, we have the 2y minus yung x natin. Ito, 2y and then the x. And then, transpose ulit natin sa other side, which is yung y natin, yung value ng y, kaya siya naging positive, and the value of 2x, kaya siya naging negative 2x. And then, divide both sides by 2y over 2y minus x. Therefore, we have the value of dy over dx is equal to y minus 2x over the 2y minus 2y minus ng x natin. And then, for the value naman natin ng m is yung sa slope natin. Na-discuss naman ito before. So, mayroon tayong formula na ginagamit dito. And sa substitute lang natin, since may given na naman tayong value dito, ito lang, base lang din siya dito sa formula natin, and substitute lang natin yung value natin ng negative 1, which is ito yung x natin. And then, yung 2 natin is yung value ng y natin. So, kapag sinubstitute natin, we have here for the value of m is equal to 2 minus 2 times the negative 1 over 2 times 2 minus the negative 1. And then, the value for m is 4 over 5. And then after nun, after daw natin makuha yung value natin ng m, which is yung 4 over 5, we can also solve for the value of the tangent and the normal. So same lang naman ito sa formula natin. Again, for the value or to get yung value ng m, we have yung formula natin ng y2 minus y1 over ng x2 over ng x1 natin, or yun yung formula for the slope. And then for the value naman dito sa tangent, application lang din yung formula natin for the tangent, which is yung value natin dito is yung y minus ng y1 natin, and then dito is yung x1 natin, and then the value of the slope or yung m natin. So the tangent is y minus 2 is equal to 4 over 5 times the x minus x plus 1. And then for the value of y, we have na yung value of 4 over 5x plus 14 over 5. Yung value ni 2 dito is na-substitute na siya, na-transpose na siya sa other side. And then for the normal naman, we have naman yung y minus 2 is equal to negative 5 over 4. So kabaliktaran lang siya nitong 4 over 5 natin. May formula din siya for that. And then times the x plus 1. So therefore, the value of y is equal to negative 5 over 4x plus 3 over 4. Dito naman sa example number 3, we have naman yung value ng sine. And ayun, pareho lang siya na sine. So differentiate sine 3 minus 6x and sine y of x. Yung first natin for the solution natin is we need to apply the chain rule on the first function to differentiate. And ayun, example natin for the sa chain rule natin, we have d over dx sine 3 minus 6x is equal to dun sa first is yung derivative nito sa loob, inside. So yung derivative ng 3 is equivalent lang sa 0. Derivative of negative 6x is negative 6. So kaya tayo nagkaroon dito ng negative 6. And the derivative ng kabuuan nito is equivalent lang siya sa cosine 3 minus 6x. And then next daw, for the second function, just jump straight to y of x for general version. And the derivative for this function is ito na siya. Given natin, we have na yung value for the sine y of x. y of x. So derivative natin nito, same lang dito sa application natin. Kukunin natin yung derivative inside. So ang derivative inside is we have the first derivative which is the y prime of x. And then derivative of nitong buo na to, derivative of sine is cosine. So we have here the cosine y of x. So therefore, ang derivative for the sine y of x is y prime of x cosine y of x. And then another example naman natin dito, we have na yung y prime or the first derivative for the x raised to 3 y times the y raised to 5 plus 3x equals 8 y raised to 3 plus 1. Kung mapapansin mo dito sa problem natin, itong first natin which is we have the x raised to 3 and then y raised to 5, application to ng product rule. Magdederive tayo gamit yung formula for the product rule. And then, yung others naman is hindi naman siya naka-product rule kasi si x raised to 3 naka-multiply kay y raised to 5. So first daw, sa solution is we have yung first differentiate both sides with respect to x and remember that y is really y of x and then the differentiation of each side for this function. So ito na yung magiging result natin after natin ma-apply yung derivative or derivation natin. We have yung 3x squared y raised to 5 plus 5x raised to 3 y raised to 4 y prime plus 3 is equal to 24 y squared y prime. And then after nun, solve na natin yung value for the y prime and then get all the terms with y prime in them on one side and then all the terms without y prime. So kanina ganito rin naman yung ginagawa natin pero we have lang yung given natin as yung dy over the dx in them on the other. And then factor down natin. Factor y prime out of all the terms containing it and divide both sides by the coefficient of the y prime. Kapag ginawa natin siya, based dun sa na-derive na natin, we have here na yung solution natin. Ito yung kanina nating given and then separate na natin lahat ng value na merong y prime and yung lahat ng value na walang y prime. And we have here na yung 3x squared y raised to 5 plus 3, ito yung walang y prime. And for the other side naman, we have lahat ng y prime which is 24 y squared minus the 5x raised to 3 and the y raised to 4. For the value of y prime, we have the 3x squared y raised to 5 plus 3 over 24y squared minus 5x raised to 3 y raised to 4. Higher order derivatives. Kung kanina, yung mga sinasolve lang natin is usually mga ano lang siya, first derivative. Since ang topic na natin is higher order na siya, hindi lang siya for the first derivative. Ayan. So for the higher order derivatives, you have na yung y prime is also equivalent nga lang siya sa dy over dx. So ito daw yung first derivative natin. Ayan, first derivative of y with respect to x natin. And then for the second derivative, nakadalawa na yung prime natin. We have the y double prime or 2 prime. Ayan. We have here yung dy prime over the dx. Equal lang siya sa d over dx times the dy over dx, or for the others naman, we have the d squared y over the dx squared. So second derivative na siya for the y double prime. And then we have naman kapag naman third derivative or the triple prime or ito, we have here naman. Kapag sinulat naman siya or sa other naman, we have the dy double prime over the dx. And then, for the fourth derivative, ganito naman siya. Y raised to 4, d over dx, and then we have yung y third prime. And so on. And let's say, we have na yung example for this problem. Ang hinahanap natin is d squared y over the dx squared or the second derivative kapag ganito na yung problem natin. And then, ang equation daw natin is, we have the 2x raised to 3 minus 3y squared is equal to 7. Ayan. For this problem, for the solution natin, ito again yung problem natin and then derive lang natin siya. For the 2x raised to 3, ang derivative natin dito is using the application natin ng power rule and same lang din naman dito is power rule and we also, dito naman is we have yung constant rule natin. So for the derivative of 2x raised to 3, we have 6x squared. And then for the next natin, 3y squared is negative 6y, y prime natin. And then for the 7 is 0 lang siya. And then separate natin yung value na merong y prime sa value na walang y prime. So we have the negative 6y, y prime is equal to negative 6x squared. And then divide both sides by negative 6y. Therefore, the value of the y prime is equivalent lang siya sa x squared over y. Kasi since we have naman yung value ng 6 pareho, both numerator and denominator, kakancel na lang natin siya. Kaya naging ganito yung value natin for the first derivative or the y prime natin. And then sabi natin kasi sa problem natin, hindi naman first derivative yung kukunin natin. Ang kukunin natin is second derivative. So bago tayo makakuha ng second derivative, kailangan malaman muna natin si first derivative. And for this first derivative natin, ang application natin dito is the quotient rule. The formula for the quotient rule is we have yung category nitong numerator natin is u. And then for the denominator is the v. Kukunin natin yung v, and then multiplied by the derivative of u, and then minus the minus yung value ng v, then derivative ulit ng u over y squared. Kaya tayo nagkaroon ng value na ganito. Sabi natin, we have yung first is yung v, which is yung y natin. And then derivative natin for the u, which is yung x squared natin, we have the 2x minus yung u natin, which is the y squared, and then derivative for y natin. Derivative is we have the y prime over the v squared. Yung v squared natin is yung y, kaya tayo nagkaroon dito ng y squared. And then after nun, kunin natin yung separate natin siya yung value ng y prime. Again natin, since we have naman dito yung value ni y, and then we also have yung value ng y squared, magiging kakancel lang tayo ng isa, kaya tayo nagkaroon dito ng 2x over the y, and then minus natin itong value na to, which is we have the x squared over the y squared times yung y prime natin. And then substitution lang ng value ng y prime natin, which is the x squared over y. Therefore, we have here the value of 2x over y minus x squared over y squared times yung value ng y prime natin na x squared over y. The value for the y squared or the second derivative natin is equivalent to 2x over y minus x raised to 4. So ito is nakamultiply na siya. X raised to 4 over the y raised to 3. Ito na po yung answer natin for this problem. Okay, last topic natin. Again, for the fourth natin na topic is interpretations of the derivative. Lahat is puro derivation yung mga ginawa natin. Yung una is chain rule, and then yung sunod is yung sa implicit naman, and then yung last natin is higher order. And then ngayon is interpretation. We have here yung rates of change. Example lang, ito is before, ito yung ginamit natin, di ba? Parang sa long method natin to ginamit for the derivation. And then, after natin na diniscuss yung long method, saka tayo nagbigay ng mga shortcut na formula for the constant rule, for the product rule, quotient rule, and power rule, etc. So, dito, for the rates of change, we have daw yung halos same lang siya ng formula natin, which is the average rate of change, which is equivalent sa f x plus h minus the f of x over h. And then we have also yung instantaneous rate of change, which is equivalent lang siya dun sa f prime x. And we also have yung limit approach, yung h approaching 0, f h x plus h minus the f of x over h natin. So kung mapapansin mo, medyo similar lang din ito, yung problem na to, with dun sa ginagamit natin na formula sa limit. Kasi di ba before tayo mag-derive nga, gumagamit tayo ng value ng h. Ito yung long method natin. So yan. These definitions are true for any function, and then x does not have to represent time. Another example naman natin dito is we have naman yung value natin for a circle. Yung sa circle naman natin, if you remember, we have yung kung paano tayo kumukuha ng area. Area for this is we have yung equal siya sa pi r squared. Kung mapapansin mo, kapag kinuha na natin yung instantaneous rate of change of the area with respect dun sa radius natin, yung formula na natin is 2 pi r. Or we have the dA is equal to 2 pi r dr. Example natin dito is for the tree-ring growth, if the change in area is constant, then dr must get smaller as r gets larger. So ito lang yung example natin for this sa example. So we have yung middle as yung first year of growth, and then kapag rainy season, dry season, and kapag yung meron tayong scarf from forest fire, yun lang siya. Yan yung next natin na application. And then additional natin, so parang ito rin yung formula natin sa limit. Yung kanina natin pinakita lang din for formula natin ng long method ng derivation, pero hindi na tayo dito gumamit ng x and then yung sa h natin. Ang ginamit naman natin dito is the value of t, and then ito for the value of the change in time. So consider natin we have the velocity. Sa velocity, needed natin is to graph naman yung displacement or yung distance traveled natin versus dun sa time. In given graph natin, we have yung x natin, ito. We have yung x natin which is equivalent lang sa time or yung hours natin. And then, ito yung y natin or the independent variable natin, which is yung distance ng or yung miles natin. So kung mapapansin mo dito sa graph, almost similar lang din siya. Kinuha lang natin yung average velocity, which is we have yung change in position. We have here yung change in position, and we also have yung change in time. So same lang siya ng formula. For the average velocity, ito yung same as formula for the derivation natin. Ayan. Okay, for this naman, we have the speedometer in your car does not measure the average velocity, but instantaneous velocity. So for the instantaneous velocity naman, we are using the first derivative. Kaya tayo dito nagkaroon ng ds over the dt. And then we also have the given limit and then yung formula na almost similar lang din sa formula natin for the derivation or yung long method natin for the derivation. And then, additional natin example is for the free fall equation natin, which is yung consideration natin dito is the gravitational constant natin. We have here for the speed, equal lang siya sa 1 over 2g times the t squared. And we have here yung value for the s natin, which is the speed multiplied dun sa value ng 32t squared. And then for the velocity, we have ds over dt, which is equivalent sa 32t. Or yung mga gravitational constant natin, we have yung gravity as equal lang siya sa 32 feet over the second squared. Or kapag meter naman, we have 9.8 meter per second squared. And then if centimeter naman siya, we have the gravitational constant as 980 centimeter over second squared. Then, additional natin for the application, we have yung sa acceleration naman. So, we have here yung acceleration is letter A. So, we have the dv over dt, or we have yung sa second derivative, which is the d squared s over the dt squared. Kapag distance natin, we have naman dito in feet, kapag gamit tayo ng feet, and then velocity would be feet per second. And then for the acceleration, we have yung feet per second over the second. Equal lang siya sa feet over second squared. And then ang example natin is, let's say we have the v is equal to 32t. So same lang siya kapag derivation, we have yung acceleration as value of 32. Kung mapapansin mo dito, parang nag-derive lang tayo ng value. Kasi in derivation, we have na yung kapag 32t, equivalent lang din siya sa 32. And then ito lang din yung relationship, wait lang. Relationship between a position graph, velocity, and yung acceleration natin. Which is yung, ito yung graph natin for the distance. And then ito is yung for the velocity natin. Let's say ang mismong given natin is we have yung acceleration daw natin is positive and yung velocity natin is positive. So, increasing daw yung sa graph natin. And then kapag naman meron tayong given na acceleration natin is given is 0 and then yung velocity natin is positive, constant lang daw siya. And then if yung acceleration natin is negative pero yung velocity natin is positive, yung magiging takbo niya is decreasing. While for kabaliktaran siya or we have naman as negative naman si velocity pero negative pa rin si acceleration, we have it also as decreasing and so on. Ayan na siya. Ganyan lang yung graph natin. So, additional example lang natin sa tangent line kasi kanina 'di ba may mga sinolve din tayo for the tangent line natin. So we have here yung example natin, slope between the points x1, y1 and x2, y2. Kasi ang formula natin for the slope again is we have the y2 minus y1 over the x2 minus x1. And then formula lang siya. Ito is application lang din for the change in y over change in x. And then for the formula for the slope at single point. So we have here f of x plus h minus the f of x over h. For the example, let's say ito yung problem natin. Example number 1. Suppose that the number of water in a holding tank at t minutes, yung time na given natin, is given by v of t is equal to 2t squared minus 16t plus 35. First, we need to determine each of the following. So we have yung letter A as is the volume of water in the tank increasing or decreasing at t is equal to 1 minute. And then for B naman, is the volume of water in the tank increasing or decreasing at t is equal to 5 minutes. And then for letter C, is the volume of water in the tank changing faster at t is equal to 1 or t is equal to 5 minutes? Is the volume of water in the tank ever not changing? If so, when? Kung mapapansin mo dito, ang question lang naman natin is nag-i-increase ba siya or nag-decrease ba siya? And then given with different given time. Ayan, yan yung problem natin. So, first is we need to get daw yung derivative of a function. Again, balik tayo dito sa problem natin. So, derivative nito is equivalent lang siya sa 40. And then, so kaya tayo nagkaroon dito ng value as 40. And yung correction lang for this problem is, itong 16 is we have yung letter t. So, ang formula na natin dito is 2t squared minus 16t plus 35. Kaya yung value nito kapag dinerive natin is 16 and for the 35 is 0 na siya, equivalent sa 0. That's the reason why we have here the first derivative as 40 minus 16. Or we also have, pwede natin siyang isulat daw, yung v prime of t is also the dv over the dt. Same lang siya as 40 minus 16. And solve na natin yung yung first problem natin, which is yung letter A. Ang first down natin na question is the volume of water in the tank increasing or decreasing at t is equal to 1 minute? The rate of change of the volume at t is 1. If we will going to substitute the value, of t as 1, substitute lang natin dito. For the v prime of 1 or dv over the dt, equivalent lang siya by negative 12. So at t, the rate of change is negative and so the volume must be decreasing at this time. Kung possible siya na pa-decrease kasi negative daw yung mismong value natin which is negative 12. And then next naman natin for the letter B, sabi natin, is the volume of tank in the is the volume of water in the tank increasing or decreasing at T5? So same lang yung gagawin natin. Magsasubstitute lang tayo ng value nitong T dun sa first derivative natin. For we have the V prime of 5, equivalent lang siya by 4. And then dv over dt is 4 lang din. So same lang siya. The rate of change is positive and so the volume must be increasing. Ayan. Kung yung letter A natin is decreasing, yung B natin is increasing. Kasi kanina negative siya, yung value natin. And for this value naman is we have the positive naman which is yung 4 natin. And for the letter C, is the volume of water in the tank changing faster at T or T is equal to 1 or T is equal to 5 minutes. The volume is changing faster at T is equal to 1 than T is equal to 5. Ganun siya. Yun yung answer for the letter C. And then for the last problem natin, which is yung letter D, is the volume of water in the tank is not changing, if so, when? So the answer for this is the volume will not be changing if it has a rate of changing of 0. Kasi syempre, 0 na din naman siya. To have the rate of change of 0, this means that the derivative must be 0 lang din. Ayan. So let's say yung derivative natin is 0, so 0 pa rin naman siya. If we have the value of T, for example, yung T natin is 4. Let's say yung 4 siya. Substitute lang natin for this value, 4 na to, di ba? Ayan. Ganun lang siya. Kasi 4 times 4 is equivalent to 16 minus 16 is equal to 0. So, din lang siya magkakaroon ng walang pagbabago. Kapag yung volume, or I mean yung T natin is given as 4. Example number 2. So, suppose that the position of an object after t hours is given by, ito yung problem daw natin. We have g of t is equal to t over t plus 1. Kung derivation ang gagawin natin dito, ang gagawin din natin na formula is the quotient rule, which is ito yung u natin and then ito yung v natin. And ayan. So, answer both the following of ayan. First is we have, is the object moving to the right or the left at t hours natin is 10 hours. And then does the object ever stop moving? So we need to know kung yung object na yan is magmo-move daw siya to the right daw ba siya or to the left with given na 10 hours and kailan daw siya mag-stop or does the object ever stop moving? Kung mag-stop daw ba siya? Ayan. Sabi ko nga, kunin lang muna natin yung first derivative. So, quotient rule nito. The quotient rule, kapag na-derive na natin, ito daw yung magkukuha natin yung value or the g prime or the first derivative, g prime of t, equal lang siya by 1 over the t plus 1 squared. Yung ito is the v squared na siya. And then yung 1 is na-derive na natin yung numerator natin. And then we have here, yung first na problem is the object moving to the right or to the left at 10 hours. So papalitan lang again natin yung value ng t natin. To determine if the object is moving to the right or the velocity is positive or to the left, if negative, we need to consider yung 10. Ito na yan. Kapag nag-substitute daw tayo, the value natin is 1 over 121. So the velocity is positive and so the object is moving to the right. Kasi sabi natin dito, kapag positive siya, to the right siya. Kapag nag-negative yung velocity, to the left naman siya. Then for the letter B, does the object ever stop moving? So the object will stop moving if the velocity is 0. Since the numerator of the derivative is a constant, it cannot be 0. Therefore, the object will never stop moving. Kasi nga yung value natin, balikan lang natin, we have here yung constant value natin which is yung 1. Kaya hindi siya mag-i-stop. Next naman natin, yung next natin na problem is we need to find the tangent line of the following function at z is equal to 3. The value is r of z is equal to the square root of 5z minus 8. Application lang to ng formula natin or the derivation for the square root. Kapag nag-derive tayo na meron tayong square root, yung numerator natin is the derivative inside. Let's say ito yung u natin. So du over dx, ito siya. Yan. And then, ito is, as is lang to, itong denominator natin. So, derivation nito, as is lang yung denominator natin na 2 square root of yung value natin. Let's say, ito nga yung u natin. So, for the derivative, first derivative, kapag dinerive natin yung 5z, equivalent lang siya sa 5. Derivative ng 8 is 0 lang siya. Therefore, the first derivative is 5 over 2 square root of 5z minus 8. And then, we have daw yung value at z. Yung z natin is equal sa 3. So, papalitan lang natin yung value natin ng z, which is, itong z natin na to is 3 kapag nag-substitute na tayo ng value natin for z dito and ito rin. Yan. So, papalitan na natin ito. For the problem, kapag nagpalit na tayo ng 3, we have the square root of 7. And then for the first derivative natin, which is yung r natin, r prime, or yung m natin for the slope, we have the 5 over the 2 square root of 7. And then, kukunin lang din natin yung tangent line. Again, yung diniscuss natin kanina, which is the tangent line, yung formula na yan. Substitution lang natin ng value ng x. And itong m natin, balikan nga natin. So, yung value nito, yung m natin, and yung value ng r natin, gagamitin na natin for this formula. So, we have yung y is equal to the square root of 7 plus 5 over 2 square root of 7 times yung z minus 3. Since ang given natin yung 3 is yung x natin. Ayan. So, ito na yung last discussion natin.